Everyone. I am Kalaimani I, Assistant Professor of CSC from KS Rangasamy College of Technology. In this video, we are going to see about the concepts of process scheduling. These are all the concepts we are going to see. Process scheduling. In process scheduling, foundation and scheduling objectives, types of schedulers, scheduling criteria. The criteria terms are CPU utilization, throughput, turnaround time, waiting time, and response time. When we go for the CPU scheduling, these are the concepts we are going to see. Basic concepts, scheduling criteria, and scheduling algorithms. We are not going to see any of the scheduling algorithms in this video. Basic concepts. The scheduling, CPU scheduling, it should maximize the CPU utilization. It is obtained through multiprogramming. This is the concept of scheduling. When we go for CPU and IO burst cycle, the process execution consists of cycle of CPU execution and IO wait. The CPU burst distribution is also an important concept when we go for the CPU scheduling. This is an example for sequence of CPU and IO burst. When we execute a program, when load, store, and read a file, the CPU engage with CPU burst. While we go for the IO operations, it has to be wait for IO. In that time, the CPU is in burst, IO burst. And next one, store, increment, index, and write to file instructions. The CPU switches to CPU burst. When it is waiting for IO devices, it is switching to IO burst. And the next instructions, IO store, load store, read from file. For these instructions, the CPU switches to CPU burst. And while we go for the IO operations or waiting for the IO devices, it is executed in IO burst. This is an alternating sequence of CPU and IO burst example. The next topic is CPU scheduler. The scheduler is nothing but it selects among the process in ready queue and allocates the CPU to one of them. The CPU scheduling decisions may take place when a process switches from running to waiting stage, switches from running to ready state, switches from waiting to ready state, or when a process terminates. These are the four cases when we go for the CPU scheduling decision. When switches from running to waiting stage. When a process is executing, then if it is in running state. When the process moves from running to waiting state, then we have to replace the running process with the another process. Which process have to take part? That's the case when CPU scheduling decision occurs when the switches from running to waiting stage. And the next one is running to ready state. It may occur when we go for the time slice expired or any process have to move from running to ready state. Then the process CPU has to get the next process for running. In this case, we are in need of CPU scheduling decision. When we go for the switches from waiting to ready, the process is waiting in waiting process goes to the ready queue. Then we have to switch the process from ready to a running state. Terminates. When a process terminates, it is in running state to terminate states, then the processor is in need of another process. The processor in the sense CPU. Scheduling under 1 to 4 is non-preemptive. All other scheduling is preemptive. For example, consider access to shared data, then it is an preemptive. Consider preemption while in kernel mode. We have to preempt the process which is in running state. Consider interrupt occurring during crucial OS activities. When any crucial OS activities occurred, interrupt occurred during the OS activities, then we have to preempt the process. The next concept is dispatcher. Dispatcher is a module which process short-term scheduler. Short-term schedulers works are context switch to user mode, jumping to the proper location in the user program to restart the program. These are all the activities involved in short-term scheduler. And the next term is dispatch latency. First of all, we have to see what is latency. The latency is nothing but the time taken to do a task. We call it as latency. When we go for the dispatch latency, what is the time taken to stop one process and start another process? The time taken by the dispatcher is called as the dispatch latency. The dispatcher's process is to stop one process and start another process to running. The time taken to do its work is called as the dispatch latency. And the next one is scheduling criteria. In this, we are having 5 terms: CPU utilization, throughput, turnaround time, waiting time, and response time. When we go for CPU utilization, we have to always keep the CPU as busy as possible. That means that the CPU is utilized as much as possible. And the next term is throughput. Throughput is nothing but the number of processes that complete their execution per unit of time. Turnaround time, it is the amount of time to execute a particular process. We call it as a turnaround time. Waiting time, the time taken by a process has been waiting in the ready queue. How much time it is in ready queue? The time is represented as waiting time. Response time is the amount of time it takes from when a request was submitted until the first response is reproduced, not the output. The first response is produced. That is the response time. And the next one is criteria for scheduling algorithm. These are the 5 criteria. The algorithm should maximize the CPU utilization, maximize the throughput, minimize the turnaround time, minimize the waiting time, and minimize the response time. These are the 5 optimization criteria for any scheduling algorithms. These are all the concepts of basic process scheduling. Thank you.